Okay, so the next piece is to sketch the following graphs using zeros and end behavior. Okay, and this truly is going to be a sketch. One thing that I want you to know, so we're going to actually just be doing cubic functions. So cubic functions, come on, there we go. They kind of look three different ways, for the most part. We have our parent function, which looks like this, okay? And then we have ones that when they get a bit more, so the parent function is y equals x cubed, okay? But when they get a bit more intense, they tend to look like this. Or if it's a negative x cubed, they would look like this. Okay, these are the ones actually that we're going to be focusing on. We are not going to do the parent function really, but it is important to know what the parent function actually looks like. You might see it on the ACT, and I know you see it at the collegiate level. Okay, but we're actually going to be utilizing these two over here, and what you'll notice is it hits the graph 3 times, which is very typical, okay? Usually you have 3 zeros for a cubic function. So we're going to actually utilize, the problems that you had in 6-2 where it said then sketch the graph. So we're going to look at, it was number 19 on page 311. So that was y equals x plus 1 times x minus 2 times x minus 3. So remember that you need for the end behavior. So first of all, actually, let's go ahead with our zeros. So our zeros are x equals -1, 2, and 3. Okay? And then my end behavior, to figure that out, you actually do need to multiply this out and get it into standard form. For sake of time, I'm just going to kind of abbreviate it, that when you multiply the 2 out, you end up getting x, oops, come on, x squared minus x minus 2 times x minus 3, and you distribute it out, but you'd notice that you end up getting a positive x cubed. So my right behavior, because it's positive, it's going to go up on the right. My left behavior, because it's odd, it's going to be opposite. Okay? So it's going to be opposite there. So then I know that it's going to go down on the left and up on the right. So utilizing the fact that I have my zeros here and I have my end behavior, I can actually go ahead and graph this. Okay? And so I'm going to pull up a little graph here. Oh, it's a little bit off. Sorry, folks. So what I'm now going to do is I'm going to first graph my zeros. So I had one at -1, I had one at 2, and I had one at 3. So this, oops. And you know what I might do? I might actually erase this page and maybe do a larger, because those are so close together. Let me actually redo this. So Let's get that here. Good. So now I have a 0 at -1. I have a 0 at 2. And I have a 0 at 3. And remember, my end behavior was down on the left and up on the right. So that means I go down on the left and up on the right. Also remember, a cubic function graph, it's kind of loopy. Okay, so if I have a cubic function graph, it's going to be loopy like this. So what I do is, now that I have my end behavior, I'm going to take it from here and I'm going to go up and then come back down and then go back up, so it all kind of makes sense. To be completely honest, we don't know really how far up or down those two loops go. We don't. And really, in order to know that, you would actually have to calculate. You would have to substitute in some values for x. We aren't going to do that. We truly are just sketching. Okay, so that's very important to know, that the two little arcs that you make, they are not necessarily, they're not going to be perfect, and that's okay. Let's look at another one where we're looking at some zeros. Let me actually do an example of one. Here's an example where we can sketch. Oops. Why did I just write a y instead of an x? So I have y equals x, oh, come on, times -x minus 2, and then times x minus 2. So first I need to find the zeros, okay? So to find those zeros, well, this first one's easy. It equals 0. This one you might need to do a little work on. So I have -x minus 2 equals 0. So then I get -x equals 2, and I have to divide by -1, so I get x equals -2. So I get -2 for that, and for this one, it's 2. You can always set them each equal to 0 and solve for x to find out. So now I have my zeros. Now for end behavior. Why isn't this taking? So now we have, oops, I'm on the eraser there. Now we have end behavior. Okay, so for that we would want to kind of multiply out. Really what I would do as a shortcut, now I will probably on a quiz or test ask you to write out the, write out the whole thing. But what you really could do is you could just multiply these three together. So I have x times -x times x, and that gives me -x cubed. So for my right behavior, because it's negative, it's going to go down. For my left behavior, because it's odd, it's going to go up. So then my end behavior is going to look like that. Okay, so that's kind of a shortcut if I don't ask you to actually multiply out to get the polynomial. You can just multiply these first three of each of the binomials, or in this case, that's a monomial. So now let's go ahead and sketch this graph. So my zeros, I'm going to sketch first. So I had 0, I had -2, and I had 2. Remember that my end behavior, it was, because it was negative, it went down on the right and then up on the left. Okay, I don't know what's going on here. All right, so then that means I need to go up on the left, down on the right, and then I'm going to kind of swoop it. It's just really helpful to start on the left, and kind of go with go with the flow, I guess you could say. It's kind of hard to describe, but it needs to make sense. And you always need to realize that a cubic function should either look like this, or, now if it'll work, my stylus is acting up on me. Or it's going to look, oh dear Lord, it's not going to look like that. Or it's going to look like this. So, so that's really important to know for cubic functions, kind of how they look, so that way you can do that correctly. So you have some work in your book as well as a worksheet to be able to graph, and utilizing the end behavior and the zeros to graph.